Hello mathematicians, here is the video for Home Connections 107 and 108. 1A, it says draw a line from the 12 to the 3, and that is 90 degrees. You could think 360 degrees divided by 4, right, if we split the clock into 4 sections, and that is 90, but most likely what you thought is that you just knew that a right angle is 90 degrees. Letter B, from the 12 to the 6, and I know that that's 180 degrees. And you could think 360 degrees, the full circle, cut in half is 180. But just like the previous one, you might have just known that a straight angle is 180. Letter C, a line from the 12 to the 1. A lot of people thought that they needed a protractor for this, but you don't. Just think. Use what you know to figure out what you don't know. If that is 90 degrees, and we think about splitting it into 3 sections, I know that must be 30, that must be 30, and that must be 30, because 30 plus 30 plus 30 is 90. So the part that they wanted us to focus on was this part. So from the 12 to the 1, that is 30 degrees. You could think 90 degrees divided by 3, which is what I did. You also could think the whole circle divided by the 12 sections of the clock. That's the way that you could have gotten 30 as well. Letter D, from the 12 to the 4. Again, I'm going to use what I just did, use what I know to figure out what I don't know. So if from the 12 to the 1 is 30 degrees, then the 12 to the 4 would be 30, 30, 30, 30, which is 120. Or maybe 30 times 4. All right, on to page 108. How to draw a 60-degree angle. If I know that from the 12 to the 1 is 30 degrees, then the 12 to the 2 must be 60 degrees. So draw a line segment from the center of the clock to the 12 and to the 2. I also saw someone in class drawing a picture, which is a great way to give directions. So from the 12 to the 1 is 30, then the 12 to the 2 must be 60 degrees. Danny is learning to do a full turn on his skateboard. So far, though, he can only do 270. So how much more does he have to do? How much farther does he have to turn? This is where he wants to be. This is where he is. And if we subtract, he needs 90 degrees more. The challenge, sketch the following if they are possible. If they are not possible, explain why they can't be sketched. A triangle, which of course is 3 sides, with parallel sides. Try to draw parallel sides. Can you connect those and only have 3 sides? I hope you think like I think. No, it would have to at least be 4 sides. So my response or my explanation will be, it is not possible. If it has a pair of parallel sides rectangle have at least 4 sides? Letter B, a trapezoid with 2 lines of symmetry. I would draw a trapezoid. I can think of a trapezoid that has no lines of symmetry. This is the only partially symmetrical trapezoid that I can think of. And the line of symmetry would be right down the middle, where the left is the same as the right, and there are no other lines of symmetry. So my answer would be, it is not possible. It can only have one line of symmetry. I'm thinking of other shapes with 2 lines of symmetry or more. A rectangle has 2 lines of symmetry. A square has 4 lines of symmetry, but that wouldn't be a trapezoid then, right? A trapezoid only has 1 pair of parallel sides, and those shapes that I mentioned are parallelograms. A pentagon with 2 right angles. I can totally do that. And I'm going to draw the 2 right angles to begin with. And I know that a pentagon has 5 sides. So I could draw a pentagon that looks something like that. I could also draw a pentagon, right? There's my 2 right angles that looks something like that. And there are other options as well, but that one is possible. Here we go. Page 107 and page 108. All right, kids, I will see you in class.